This is Mr. Arnold here, and we are going to talk about writing chemical equations and writing chemical formulas today. It's not too difficult to do. A few things you have to know how to do, which I think you already do, which is find the symbols and also find the charges. It won't be too bad, I promise. It will be easy to do, and we'll start you off really simple today. And hopefully you'll get this mastered before too long. All right, so let's look at our stuff here. Okay, so this is lesson STEM 2.3. Oops, let's try that one more time. I thought it would be much cooler. This is lesson STEM 2.3. And it still isn't erasing. And let's look at what I have written down here. And this is in your notes. All right, it says, first of all, it says write the positive ion with the charge. Now, I'm just going to make one up here for the first one. And our positive ion with the charge, I'm just going to say Mg. Okay, so Mg. And Mg is plus 2. Now, when it says positive ion, that's also known as a cation if you're keeping track. But write the little charge above it, just like I did right here. Right? Just do that exactly that way. Second thing, write the negative ion with the charge. And so I'm just going to pick a random one. I'm going to pick Cl. That's a common one, right? So we'll put Cl here. And Cl's charge is minus 1. Now, you're saying, how am I finding these charges? Well, the charges can be found a few different ways. One way that we found charges before was with the old periodic table. Well, and I picked one that doesn't have it. Well, the way we pick charges, and this is for most of the elements on the table, is the first column. Let's change that to a nice bright pink color. Everything below that, in that first column, is plus 1. The second column, plus 2. Plus 3. We get to this next section, it could be plus 4, or it could be minus 4. We're going to go to the other side. The end column is 0. You'll never have to use that. Minus 1, minus 2, minus 3. Now, for the most part, that is the way the charges are set up. But there are exceptions to this. And so we do have another table that has charges on it. If it's in the first column or it's in the second column, I'll put myself in the D block. How's that? Ooh, I have a transition now. So if we have the first column or the second column, we have this column here, or any of these, they're pretty much going to be those charges. When you get into the D block, there's going to be different charges that can occur. And there's no way just by looking at the table what they would be. So our second way of finding charges would be to use this little chart that I have right here, and it's called the ion chart. And this ion chart is set up almost the same as what we had before, but if you look at the ion chart, right, the first column, these were all plus 1, which we just said they would probably be. The second column are all plus 2, just like we said they would be. Now, you get to this third column. Things get a little wacky over here. Most of them are plus 3. B is actually plus 3. It's not written on there for some reason. Aluminum plus 3, Ga plus 3, In plus 3. And you get down here, and that one could have a charge of either plus 1 or plus 3. Okay, so it does start to vary a little bit. Let's go to the next section here. Let's go to this nice green color. And then carbon's family, these are usually plus 4, but you get down here tin, and it's plus 4 or plus 2. You look at lead, lead's plus 2 or plus 4. So there are variations, so you might want to use this chart to get everything straightened out. The next section, again, there's a little bit of variation in here. And you can see those on your chart. I think there's a clearer chart down here. I think I just picked the wrong one. Oh, there it is. Yeah, that's much clearer. There's a little bit clearer chart, third row down. I had this bad one on there, and I didn't delete it. And for some reason, I put a new one over top of it, right? And then we get to this section, and these are going to be mostly -2s. And then we get down to the bottom, and it goes and changes again, all right? And then finally, our halogens, well, our halogens are set. We know our halogens are going to be -1 because that is what halogens do. And the noble gases you don't have to worry about. Now, if you look inside the D block, everything's a little wacky and crazy and changed around. Just have to use this chart to figure out what those charges are. Okay. Let's go back to writing the formula. Where is it? All right, so you have Mg plus 2 Cl minus 1. If we look on that table we just did, you'll see that those were the charges they had. Okay, now we're going to do something I call crisscross. If you have a 2 up here, you're going to go down here, and you're going to put a 2. Don't draw the dotted lines. That's just to show you where I'm going. Then you're going to draw a 2 down behind that. If you have a 1 up here, you're going to draw a 1 here. Now, remember we talked about this. The 1s are optional, so you don't really need to write a 1 there. But for starters, if you want to start out doing that, that's awesome, right? It'll be good, right? I mean, it's not going to hurt anything. It's not going to hurt anything at all. You might as well do it, right? You get it, all right? And then if it needs to be reduced, you reduce it. Now, this one doesn't need reduced. When I'm talking about reducing, I'm talking like a fraction. I'm going to change the size of this font just a little bit. So if I had a fraction 1/2, that's already reduced. I can't change it, right? 1 and 2. Can't reduce any further. Let's do one that we can reduce. Okay, I'm going to say carbon and oxygen. Carbon, if we look on our chart, well, I won't even look on the chart. Let me get back to where it was. We look on the chart, and carbon would be +4. Okay. Oxygen, right? Oxygen's a -2. All right, now, we're going to do our same thing, our crisscross. I'm going to change colors to make it look prettier. So if I would change this, I would put a 2 here and a 4 here. Now look at that. 2/4. That's like a fraction that needs reduced. That's what the reducing I'm talking about is. Okay? So you have to reduce those down. How do you reduce it down? Just change. I got a text here. Hold on, let's get out of the way. Okay, it has to change it to a simpler form. So it was 2 and 4, so we're going to change it to 1 and 2. Just the same way you would reduce a fraction. Okay? That's pretty much it. That is all writing formulas is. Let's see what happened. Oh, sometimes there's polyatomic ions. And remember, polyatomic ions were those ions that I had that were, let me see, so you can see it. So those were ions that I had that were in special parentheses. Okay, so remember that from the other day. So I'm going to make one up again. I'm just making this one up off the top of my head. This is a real formula, but we're going to start off with aluminum. And if you look up the charge of aluminum, it's +3. Now we're going to write down sulfate. Now, sulfate was a polyatomic ion, I think, that I showed you yesterday. I think I drew the picture of it yesterday. So it should sound familiar. I mean, I don't expect you to memorize that or anything, but it should sound familiar. And sulfate, remember, it had extra electrons, so it has a -2 charge. Here's the key. The reason we use these polyatomic ions like this is because we can do the same exact thing that we did before. We're going to crisscross. Put the 2 behind the aluminum and the 3 outside the parentheses. Remember I said when you use a polyatomic ion, use parentheses so you know it's a polyatomic ion? You need it. You need it here. If you don't have the parentheses, it messes up the whole formula. Because look, now it says I have 43 oxygens. I don't have 43 oxygens, right? No, we need to be in parentheses so we can say that we have 3 sulfates. And can it be reduced? No. It's good to go. It's done. Right? That's writing formulas. Now, I have a paper attached on Schoology called Writing Formulas. So let's go to that now. Writing formulas. There's a polyatomic ion right off the top. And look, this first page, I went ahead and I put the charges on there for you. Now, if you do this in Kami and Schoology, you shouldn't have to even rewrite the symbols because I tried to make them big enough so you could do it. So all we have to do is crisscross. And we're going to take the 2 that was on the S and we're going to write it behind that thing in parentheses. The 1 that's above that, that's ammonium, by the way, but you don't need to know that right now. You put a 1 behind that. That's it. You're crisscrossing. If it can reduce, it gets reduced. If it doesn't reduce, it stays as is. Now, I added 1s on there because, I'm a rookie. I want to be sure that I'm crisscrossing right. Just do it that way in the beginning. You're going to outgrow the 1s. We know that. You're going to pick it up in a second. As soon as you figure it out, great. You don't need the subscript 1s anymore. But if you're having troubles, use those 1s until you're ready. What I mean by ready, it means you can do it. All right, look up here. I'm jumping over here because a 1 and a 2. That's it. Okay. Now, notice, I didn't put any little charges down below. Some people start doing this and they want to crisscross. They want to write a negative here and a plus. You don't do that. No. You don't have a negative atom. You don't have a less than 1 atom, right? So don't make it look like you do. Get that negative out of there. Get that positive out of there. That just makes it ugly. We want to keep them pretty. Okay. Hg2, or Hg plus 2, and then O minus 2, right? So if I put a 2 here, and I put a 2 here, don't really do it yet because it's a trick. No, that's reduced. That's a fraction, right? So we're not going to put those 2's there. In fact, since they're both 1s, you don't have to write anything. But since we're just starting, a 1 and a 1. Okay, that is writing the formulas. Go through there. All you have to do is crisscross on this page. Oh, look at this beauty. Ooh, that looks so tough, right? No, it is not tough at all. We got this. All right. I'm going to the next page. Oh, look out for your reductions. I'm just going to say that I think it's just 33 is the other one that needs reduced. Let's go up. Oh my gosh, Mr. Arnold, you didn't put charges the next page. That's right. So now you're responsible for finding those charges. So you're going to have that chart that I have. Remember, the bottom chart is better. The hardest part of this paper is going to be for you to find those elements on the table. That's going to be the hardest part. So you just have to look for them and find them. There's some that have multiple charges. Put them on, I wasn't thinking, right? You can choose the charge of your choice. It's got to be from the table. It's got to be one of the possible charges, but you get to choose. Let's do one that can be like that. We have SNCl, which is, SN is tin. I'm behind that right there. So I'm on this one, SNCl. So the first thing I'm going to do is I am going to go back and I'm going to look on my chart. I know your chart doesn't quite show up as quick as mine does, but it's all right. And here we go. SN. And again, I know these. You might not know them yet. There it is. Look at that. So SN can be +4 or +2. today's your choice. Writer's choice. Let's pick the 4. That seems cool, right? All right, so that's Sn is going to be plus 4. And it was Cl. And Cl is, move with me, the screen's lagging on me. The Cl is minus 1. Back to the paper. A is in the same spot. So we said Sn would be plus 4. Cl is minus 1. Crisscross. You can write the 1 there if you want, but you know that it doesn't have to be there. I'll do it. You talk me into it. Polyatomic ion, right? Right? Well, there's a, oops, right? There's a chart for that too. So we're going to use our charts. I have to flip back. And ion chart. And the first thing, I forgot what it was. What was it? What was I drawing? Wrong paper now. There it is. It was zinc. Okay. Zinc and then SO4. Okay. It's in parentheses, right? That thing in parentheses, SO4, that's a polyatomic ion. So there's a whole page for those. All right. I got it. Zinc sulfate. Got it. Let me check it out. So I'm going to go to my chart. First of all, I'm going to find the zinc. There it is, right there. Right at the end of the D block. Right? So zinc is plus 2. Sulfate. Okay. Now, this chart, it has some of the common ones up here on the front of this chart, right? So I put those up there so you could find those. Those are there. But there's also another chart on here that has them too. So look at that. And it says SO4 minus 2. They don't have these in parentheses. They should. I should have went through and did it. I don't know if I can do that with a PDF. But it's SO4. We're going to think of that as in parentheses. SO4 with a minus 2 charge. SO4 with a minus 2 charge. Okay, look at our things. 2 and 2. Now, you can write 2 and 2 down here and say, oh my gosh, I have to erase this. It seems like that's a pain in the butt. But you can realize that it's 2 and 2, and that will reduce down to 1 and 1. Okay, so the polyatomic ion charts, the polyatomic ions are, charges are in the chart on that second page. Let's look at that one more time. Okay, so here's the charts. Now, look at the number. That's supposed to be like a subscript. So this would be PO, oh boy. So it'd be PO4 or PO3 with a minus 2 charge. PO4 with a negative 2 charge. CO3 with a minus 2 charge. This whole column is the negative 2s. And so all of these things on these pages should have parentheses around them. You know, the rule is if there's only one of them, you don't need it. But I find it easier for you guys if we just put them in parentheses every time. It's not hard to do. It's only 2 little lines, and it splits it up a little nicer. Okay? So I know this may be a little bit more difficult on this side, but hopefully you'll get it figured out, and I think you'll do just fine. All right, thanks a lot. Have a great day.